Hi, this is a video about simplifying rational expressions. Please watch with sound on. Thank you. Here is number one. And if you don't have the assignment in front of you, it doesn't matter. You could just copy down this problem and do it with me. Now, our goal is to simplify this. To be able to simplify this, we're going to need to factor it. And when we're factoring, we want to ask ourselves, first question, is there a GCF? And we're going to ask that question about the numerator, and then we're going to ask it about the denominator. So if we look at our numerator, if I look at the integers, I don't see a greatest common factor because the greatest common factor can never be bigger than the smallest number. So the only thing that goes into 1 is 1. So there's no integer greatest common factor here. However, there is a common factor in the variables. So in the variables, we can see that each of these variables has at least x to the third power within it. So I'm going to put x to the third power outside the parentheses. And what I'm basically doing now is subtracting exponents. X to the fifth divided by x to the third is x squared. And notice that 3 plus 2 takes me back to 5. Now x to the fourth divided by x third, that's going to give me just a plain old x. Right, there's a divisible 1 here. And then x cubed divided by x cubed, well, that cancels those out. So what should happen is if I distribute this x to the third back, I should end up where I started. X to the third times x squared, x to the fifth. 12x times x to the third, yes, 12x to the fourth. 36 times x to the power 3, yes, 36x to the power 3. Is there a greatest common factor in the denominator? Notice I'm looking at these separately. They don't have to have the same greatest common factor on top as it does on the bottom. So in the denominator, I see that both terms have a variable. Oh, by the way, this has a 1. And so the only thing that are factors of 1 is 1. So there's no greatest common factor in the integers. However, since they both have x's, then I can factor out the greatest power of x, which in this case is 8. So I can factor out an x to the power of 8. And I have x to the power of 11. If I divide that by x to the power of 8, I get x to the power of 3, right? Which is basically subtracting 11 minus 8. I didn't do anything as far as the integers, so I still have that 216. And since I took out the x to the power of the 8, it's not here anymore. That's only step 1. My next step is to look and decide how I'm going to factor it. So let's just look at our numerator for a minute. We already did the GCF. And then if I look at what's inside the parentheses, how many terms are there? Well, there are 3 terms. Which factoring method is best for this? Well, since it has 3 terms, my choices are perfect square trinomial, big X, or special big X. And let's see if it works for perfect square trinomial. So if something is a perfect square trinomial, it has an a square at the beginning, and then it could have a plus or a minus here, and then it ends with another number squared. So this could be x times x, this could be 6 times 6. In the middle, I would have to have x times 6 times 2, right? 2ab. That works. That works. This is a perfect square trinomial. And so when you factor a perfect square trinomial, you get either a plus b times a plus b, or you get a minus b times a minus b, depending on which sign you have here. So in this case, it's a plus sign, so that's going to give me x plus 6 times x plus 6. So I'm going to rewrite this numerator. I'm going to go ahead and go over here. I'm going to keep my x to the power of 3. And I'm going to substitute now because I figured out that this is the same as x plus 6 times x plus 6. Could you have done big X and gotten x plus 6 and x plus 6? Sure, but I really wish that you knew that perfect square trinomial shortcut. Now let's look at our denominator. We already handled the GCF. Now inside parentheses here, we have 2 terms. So which factoring method would we use? Sum of cubes, difference of cubes, or difference of squares? Well, cubes are things to the 3rd power, right? So if you have an x to the power 3, then you have a sum of cubes or a difference of cubes potentially. And that's a sum. And then the only other question we have to ask ourselves is 216, can you write it as something cubed? And you can. It's 6 times 6 times 6. So this could be x to the power 3 plus 6 to the power of 3. So that would mean my a is the same as x in my formula, and my b is the same as 6 in my formula. So let's do our formula. Your formula is a plus b. I can't believe I just wrote a b there. I'm going to make it into a 6. And then it's a squared. And then ab 6x. I'm going to use SOAP in a minute. And then b squared, 36. To do our signs, we have to look at our starting sign. This is always the same as our starting sign. This sign is always opposite of our starting sign. And this one's always positive. Same, opposite, always positive. Okay, look, I factored it. Now, this has 3 terms. Should I try to factor it? The answer is no, because this trinomial will never factor if it's part of a perfect square if it's part of a sum or difference of cubes, this will never factor any further. So you already know that you've arrived. So now it's time to look at what can cancel. These are called monomials, right? They're one term, nothing is added or subtracted. So I can simplify these as if they were their own fraction. If this were x to the 3rd over x to the 8th, I would subtract the exponents, and I would have an x to the power of 5 on the bottom. You could put a 1 here if you'd like, but you don't need it. And again, subtract the exponents. I have x to the power of 5 on the bottom. I can cancel this x plus 6 and this x plus 6. They're in parentheses and they're identical. And then what does that leave me with? It leaves me with x plus 6 on top, and on the bottom, x squared minus 6x plus 36. And I don't need this one, so I'll just... And that's the answer. Now, if you've used my help a lot on this, then if I were you, I would come back and do this one independently, maybe after the video. Okay, next one. Let's go on to number 2. And again, if you don't have this assignment, that's okay. You could just copy down number 2. And I strongly encourage you to try these on your own before you watch the video with me, or watch the video of me doing it. What we would get here is sorry, I got distracted there. I'll probably cut that little part, or maybe I won't because I'll be in a hurry. These are all monomials. There is no adding or subtracting in either of these expressions. So what we could do is we can simplify either numerator on top of denominator, numerator on top of denominator, or we can go this numerator to this numerator. This numerator to this denominator, this numerator to this denominator, because I really don't want to multiply these big numbers. So can I do 33 and 55? Yeah, they both divide by 11. So 33 divided by 11 will get me 3. 55 divided by 11 will get me 5. 14 and 28. They both divide by 7. They also both divide by 14, but let's just pretend for a minute you thought it was 7. This would get you 2 over 4. But look, 2 over 4 simplifies again. That becomes a 1 over 2. So if I had divided by 14 to start with, I would have gotten 1 over 2. But let's say I divided by 7, I would have gotten 2 over 4. And then I simplify my 2 over 4 to be 1 over 2. What's left to deal with? I have x to the 5th and x. Well, this x is going to disappear. It's going to be canceled out by one of these x's, which will make that an exponent of 4. So now I need to be pretty careful, make sure I'm doing this right. I have 3x to the power of 4. Oh, times 1. That's great. So it's just 3x to the power of 4. Over here, I have 2 times 5, and this x was canceled out. So that gets me 10. That's it. Let's go on to number 3. Now, when we're dealing with a multiplication problem, we're going to follow the same steps that we did here, but we just have to do all 4 pieces before we can multiply. So the first thing I'm going to do is I'm going to look at all 4 pieces and see if any of them have a greatest common factor. So when I look here, I know I don't have an integer greatest common factor because this is 1, nothing else goes into it besides 1. So that's going to not have any integer common factor. Both terms do not have an x, so there's no variable common factor. Therefore, that one is going to stay. In fact, let's just go ahead and rewrite it now, because that one is not going to change. What about here? Now, if you have integers, you should look at your smallest integer and see, can my smallest integer be a factor of my larger integer? It is, right? 6 times 4 is 24. So let's factor out a 6. And then they don't each have an x, so I'm only going to factor out the 6. And so if I divide 6x squared divided by 6, I just get x squared. 24 divided by 6 is 4. And I should always check, if I multiply this back, 6 times x squared is 6x squared. 6 times negative 4 is negative 24. I'm right back where I started. That's exactly what I want. Let's look here. Okay, we have 2 integers. Neither one of them is a 1. And then we're going to ask ourselves, is 20 a factor of 40? It is. It's 20 times 2, right? So let's take out the 20. And then what about x's? Ooh, they both have x's. So look at the smallest degree of x. So that means that x to the power 3 is coming out. We can think of what is 20 divided by 20. That's 1. X to the 4th divided by x to the 3rd. Remember I said it's pretty much like subtracting exponents? So that just gives me x, right? 20x to the 3rd times x is 20x to the 4th. 40 divided by 20 is 2. X to the 3rd divided by x to the 3rd, that's 1. So 20x to the 3rd times 1 times x is 20x to the 4th. 20x to the 3rd times negative 2 It's 40x to the negative third. So I'm doing great. Okay, integers. 2, 13, 7. 2 is the smallest one. Does 2 go into 13 or 7? No. Is there any other number? Nah, because 2 is only 2 times 1. So, and 13 is only 13 times 1. So that actually does not have a GCF because there's no x over here. So I'm going to keep that as it is. Okay, that's just one step though. I've got a ways to go. So let's look at this top one. We decided there was no GCF. It has 2 terms. And so if we have 2 terms, it could be sum of cubes or difference of cubes, but there are no cubes there. There's nothing to the third power. So that leaves me with difference of squares. If you have something squared minus something squared, then the formula says you end up with a plus b, a minus b. Most people really like that formula. I know I do. So the a and the b here would be x and 7. And it always ends up being a plus and a minus. Okay, that came right from here. I'm going to keep this 6. This is also difference of squares. Look, x times x, 2 times 2. So this is x plus 2, x minus 2. Also notice when you're doing like your A's and B's, the A and B part is always smaller. Like, you know how we had 216 here? The B ended up being 6. 6 times 6 times 6 is 216. You know how we had a squared plus 2ab plus b squared? Look at my a plus b. It's just x plus 6. It's much smaller than either of these. Okay, so here, when I'm thinking of my b, it better not be the same. It better be smaller. All right, let's see what we have here. Hey, you know what? Let's keep this 20x to the power 3. I know this has 2 terms, but since there's no x squared or x cubed, there's nothing we can do with it. We're stuck with it for the moment. Is this one a perfect square trinomial? Nah. 2 is not a perfect square. 7 is not a perfect square. Wah, wah. So how do I factor this? Well, big X or special big X? It's going to be special big X. And what I'm going to do is I'm going to keep my work nice and neat. I'm going to do my special big X over here so it doesn't get in the way. So if you can do special big X without my help, by all means, please pause right now and do special big X and come back and see if you got what I got. So I'm going to go ahead and rewrite my trinomial here. And my x, a times c, negative 14, negative 13. Always look at the multiplier. So it's either 2 times 7 or 14 times 1. So it's going to be 14 and 1. If you remember my trick, I always put the bigger number on the left. And this sign should match. That makes sense. Negative 14 times 1 is negative 14. Negative 14 plus 1, negative 13. Here's the step everybody forgets, and I think it's because Photomath does it differently. You're going to bring down everything. Actually, Photomath does it the same. It's just you guys don't remember what comes afterwards. Zoom in a little bit there. A little bit of light on that. Okay, so I brought down my 2x squared from the top. This negative 13x squared negative 13x has been split into negative 14 and 1. And the negative 7 has just come down. Okay. Now, this is the part people seem to forget because, again, I think it's not explained very well on Photomath. What you're going to do is you're going to look at these first 2 terms right here. and find the greatest common factor. This is where we're regrouping things. So I'm going to say, hey, these both can be divided by 2x. And that gives me x minus 7. Whatever sign this is, I bring this down. And then the only greatest common factor here is 1, x minus 7. Then I take this 2x and this 1, and I make them into their own factor. And I take the x minus 7, and I make that into its own factor. And I got it. And in case you've forgotten, if you multiplied these back together by distribution, you'd get back to this. Okay, so all I'm going to do now is take these factors and write them here. Whoops, I wanted to write it in the same color, actually. So using this marker, there we go. 2x plus 1, x minus 7. Woo! Okay, so these things are all factored now. Okay, I took these all through a process to get them down to their most factored form. Now it's time to see if I can cancel anything. 20x to the power of 3 is a monomial, meaning nothing is added or subtracted to it, only multiplied. The same thing with the 6. So in a way, you could think of 20x to the power of 3 over 6 as going here, and then you would simplify it. You could divide top and bottom by 2, and that would get you 10 over 3, and the x to the third is going to stay put. So that's 10x to the power of 3 over 3. Right? So this became a 10. Oops, let me make that a little clearer. Because I divided by 2, this became a 3. Now let's look at all of our factors here. Here is x plus 7. I do not see another x plus 7. Here's x minus 7, and there's 1 in the denominator here. So I'm allowed to cancel as long as it's numerator, denominator. Here's an x minus 2. I can cancel that. I think I've done everything I can. I took this 10x to the power 3 and I put it first. That's just how people generally do it. The only other thing that remains on top is x plus 7. On the bottom, this 6 became a 3 because I divided both of those by 2. And I think what I have left here is x plus 2, because it never canceled, and 2x plus 1. And that's my answer. I want to go back and check, make sure that I didn't do anything incorrectly on my canceling. Like the minus 7 canceled with x minus 7, x minus 7. X plus 7 stayed. X plus 2, 2x plus 1. I got it. Again, this one had several parts to it. Try it on your own. If you had to do that like with my video, now try it on your own. Okay, number 4. Let's see what's next. Another multiplication problem. Ooh, lots of things with 2 terms. So the first thing we're going to ask ourselves is we're going to ask ourselves about the greatest common factors. That's the first thing we have to do. So let's look at 25 and 9. Well, 25 is 5 times 5 or 25 times 1. In fact, that's really all it is. I don't think you have any other choices there. And 9 is 3 times 3 and 9 and 1. So they don't have anything in common. So these integers are going to stay. But they both have an x, and that means you can factor out the smallest degree of x. So this is going to become x to the power of 5 on the outside. If I take 25x to the power of 7 and divide it by x to the power of 5, that means I'm subtracting exponents, and the 25 stays, and I have x to the power of 2. If I multiply these back together, I should get back to where I started. The 9 stays. The x to the power 5 came outside. So that's it. I factored out my greatest common factor. There was a x to the power 5 inside this x7. There's an x to the power 5 right here. Okay, let's look at this denominator. Integers. You can divide both of those by 2. I think that's the only thing. So I'm going to go 2. There's not an x in both terms, so can't do that. 10x divided by 2 is 5x, because 2 times 5x is 10x. Negative 6 divided by 2 is negative 3. Hey, these both have a 12. That makes my life easy. 12. X squared means I can take out an x. Ooh, what is 12x squared divided by 12x? 12 divided by 12 is 1. X squared divided by x, remember we're subtracting exponents, so I would just have an x. What is 12x divided by 12x? Anything divided by itself is 1. What do I have over here? 30 and 18. 18 is 9 times 2, or 6 times 3, or 18 times 1. 9 does not go into 30, but 2 does. 18 does not go into 30. 6 goes into 30. So of all these things that go into 18, 6 is the biggest one that also goes into 30. So I could take out a 6. X to the power of 8 is my smallest degree. 30 divided by 6, x to the power of 8, would give me 5. Subtract your exponents, x. 18, x to the 8th divided by 6, x to the 8th. 18 divided by 6 is 3. x8 divided by x8 is 1. So there I have it. You know, all we've done so far is the greatest common factor step. So the next thing is we have to see if we can factor what's inside the parentheses. So if I look here, I have 2 terms. It's not cubes because there's no x to the power of 3. So I have to ask myself, is it difference of squares? Is this a perfect square? It is. 5x times 5x. Is this a perfect square? And we forgot about the negative, just look at that. 3 times 3. Yeah, so it could be 5x plus 3 and 5x minus 3. And then, hey, do you notice, like sometimes you could kind of get an idea where these things are going. So this was difference of squares. So I'm going to do x to the power of 5. 5x plus 3, 5x minus 3. By the way, it doesn't matter if you write the 5x minus 3 and then the 5x plus 3. Fine either way. 2 terms here, but it's not squared. It's not to the power of 3. It's just going to stay. Okay, if it's not to the power of 2 or not to the power of 3, then you can just leave it. Ooh, it's almost ready. Okay, let's keep this. Hey, you know what I might do right now? I could already simplify right here. In fact, I think I'll do that because it'll make things a little easier later. So this could become a power of 7, right? X and x to the 8th. And the 12 and the 6, I could divide top and bottom by 6. And this is a 2. So then what happens on the top here is the x disappears, but the 2 is still here. And on the bottom, all I have is x power 7. You could also do that as side work. You could come over and say, what if my fraction were just 12x over 6x to the power of 8? Then it's a little easier to see. That would be 2 over x to the power of 7. It's not to the power of 2, it's not to the power of 3, so I'm stuck with it. Not to the power 2, not to the power 3, so I keep it. And now that everything is factored, we are ready to cancel. This is my favorite part. So let's see what we have here. I look at the monomials first. Now you could do this as side work. I could say, what if I had something that was 2x to the power 5, right? These aren't added or subtracted, they're just multiplied. And then on the bottom, I had 2x to the power 7. The 2's would cancel. The x to the 5th would get canceled out, and all I would be left with is x to the power 2 on the bottom. Or I can do it from here. The 2 and the 2 cancel, again, because they're not in parentheses and they're not added or subtracted. X to the power 5 is going to get all canceled out by this one, and this is going to become x to the power 2. And so I don't lose track of things, I think I'm going to write that right now. Now, you don't have to write a 1 in the numerator unless everything else is going to cancel. So I don't think everything else is going to cancel, so I'm just going to write my x to the power 2 from the bottom here. Now let's look at everything else that cancels. 5x plus 3, 5x plus 3, they're identical. 5x minus 3, 5x minus 3. So what am I left with? Oh, wow, I didn't need this long line at all, because all I'm left with is x plus 1 on top over x squared. That's the whole answer. This whole thing turns out to be actually the same, just about, as this. That's wild. I draw that line way too long. So that would be a very fun one to try on your own. Again, to see if you could get all those cancellations. I think we have one more, the grand finale. Okay, I mean, this would be a great one to try on your own. But if you want to go ahead and do it with me, let's do it. We're going to look for greatest common factors first. It's not a greatest common factor here. This is a 1. This one doesn't have an x. So I'm just keeping x to the 3rd minus 64. Greatest common factor here, well, the first thing you want to look at is the smallest integer. Does 10 go into each of these? Why, yes. You could just cross off that 0. That's the same as dividing by 10, is if every term has a 0. So what about x's? X to the 7th, right? So I'm taking out 10x to the power 7. 10x to the 9th divided by 10x to the power 7, 10 and 10, and 9 minus 7, that gives me x squared. And if I multiplied those back, I would get 10x to the power 9. 30 divided by 10 is 3. I took out x to the power 7, so that just gives me 3x. And then 180 divided by 10 is going to be 18, and the x to the power 7s are taken care of. And that gets me 10x squared. If I multiply it back, I'd get 10x to the 9th. 10 times 3 is 30. x7 times x is x to the 8th. 10 times 18 is 180. And x to the 7th, x to the 7th. I got it. Okay, greatest common factor. Oh, 5, right? Look at your smallest number. Is it a factor of the biggest number? Yes. And there's an x to the power 1. Let's do it. 5x squared divided by 5x, that just leaves you with x. 15x divided by 5x, that gives you plus 3. Okay, no greatest common factor here, because you have, there's no x here, and since there's a 1 here, there won't be an integer GCF. So for the moment, I'm just going to leave that. And if you're thinking, well, what if I wanted to factor these two right now? You could. For the sake of this video, I'm trying to keep it like really logical. But if you wanted to go ahead and factor that in this step, that would make sense. Okay, here we go. Let's look at this top thing. How many terms? 2 terms. Is there a cube? Yes. Is 64 a perfect cube? Yes. Could it be a to the power 3 minus b to the power 3. Yes, it's x to the power 3 minus 4 to the power 3. So let's go ahead and do that. A minus b will be x minus 4. Then my formula says I have an x squared, an ab, and a b squared. Right, 4 times 4 is 16. So now I'm going to do SOAP. Same sign I started with, opposite sign I started with, always positive. Okay, this 10x to the 7 is a monomial. It's going to stay. 3 terms. And if it has 3 terms, it's going to be a perfect square trinomial. Big X or special big X. Is it a perfect square trinomial? Nah, because 18 is not a perfect square. So then we ask, could it be big X or special big X? Regular big X is fine, right? Again, I'm going to go over here and do it as side work so it stays out of the way of the stuff I'm going to cancel. So regular big X, because this is a 1, remember, if A is 1, do the big X, find the factors, almost done. Negative 18, negative 3. Of course, you're going to pause and figure out the factors. Then you're going to come back. 6 times 3, negative 6, right? These signs match. Bigger number. That works. Because it's big X, I don't have to do the bring down. I just write x minus 6, x plus 3. Don't even talk to me about flipping signs. That's not a thing. X minus 6, x plus 3. And you know why I'm a little bit happy too? Because look right here, there's an x plus 3. So that kind of tells me I'm probably on the right track. So this monomial doesn't do anything. X plus 3, it has 2 terms, but it doesn't have a square or a cube. So it's stuck. 3 terms. Is it a perfect square trinomial? Let us see. Why, yes, it's a perfect square trinomial because I have a squared because that's x times x. B squared could be 4 times 4, right? So this could be x to the power 2. The 16 could be 4 to the power 2. And then 2 times x times 4 would be 8x. And it's okay to have a negative. And if you have a negative here, then it's going to be a minus b, a minus b. So that's going to get me. A is x, so x. And then b, remember it's going to be smaller than any number you see here. Since 16 is b squared, then b is just 4. So a minus, or x minus 4, x minus 4. Yes, you could get it with big X also, but it's a lot easier this way. Oh, and I'm ready to cancel. Yes. I'm going to look at my monomials first. Some people are more comfortable doing the monomials as side work. So I could write that 5x over the 10x to the power 7. Divide top and bottom by 5. That would get me 1 over 2. Subtract exponents. Oops. And that gets me x to the 6th. Right? X to the next 7. So when I come over here, I'm not going to write this 1 in the numerator. The only time I have to put a 1 in the numerator is if there's nothing else in the numerator. But there's going to be other stuff. So I'm going to write my 2x to the 6 right here. So I already handled this, right? This is where I got my 2. And this became the 6 here. And this got absorbed by that. Okay. Do I have an x minus 4? Why, yes, I do. X minus 4. X minus 4. Do I have an x squared plus 4x plus 16? No, I don't. So you're staying. Do I have an x plus 3? Why, yes, I do. Okay, let's see what is left over. The only thing I have on top is this right here. Everything else cancel. So I don't really have to put it in parentheses if I don't want to. But if you do put parentheses there, that's okay. On the bottom, I already had this 2x to the 6th. This x minus 6 never canceled. And this x minus 4 didn't have anything to cancel with. Remember, this will never factor because it came out of a difference of cubes. So this is never going to go anywhere. X minus 4. And that is my answer. And that was the entire assignment. Again, if you watched this video and you got a lot of help from me on it, you need to go back and do these on your own so that you can do them independently in an exam setting. Good luck on the exam.